So for the second part of class here, we're going to switch gears. We're still talking about geometry, but a little bit different type of geometry. We're no longer going to be looking at the spatial and the areas and volumes and stuff like that. We're going to be looking now at more of the algebraic connection with geometry. There are a lot of times where we need to display numbers. We've already displayed numbers, single numbers, way back at the beginning of the semester when we were talking about negatives and doing addition and operations with integers and stuff like that. We displayed them on a number line. And one of the ways we displayed them was with a vector. Where we took, the number 6, for example, would be a vector, started at 0 and went to 6, an arrow like that. That represented 6. If we're going to represent a lot of numbers, though, that gets to be kind of a clogged version. And that's more of an operational version. That vector allows us to combine numbers and do operations, addition, subtraction, multiplication, and so on. The more abbreviated version of representing 6 is to just put a dot at the 6. That represents the value of 6. Well, in math, there are a lot of times, especially if we're working with data and stuff like that, where we're concerned about the connection between two numbers. So we have two numbers that are related to each other, and we want to look at the two of them together. Well, on a number line like this, showing a connection between two numbers is kind of difficult. I mean, I suppose if, let's say I had 6 and 9, I could put another dot at 9 and connect them with a line, but that would get cluttered very quickly as well. A man by the name of Rene Descartes came up with a method of showing the two numbers and showing that they were connected without getting too cluttered. And what he did was he used a number line, just like the one we've been looking at. And just, as always, positives to the right, negatives to the left. And that was going to be used to show the first number. And he called this the x-axis, or sometimes called the independent axis. If you're looking more at statistics and data representation, it's an independent axis with a more significant meaning to it. But then to show the second number, he took a second number line and he put this one vertically instead of horizontally. Pretend that goes straight up. The 0 was at the same spot as the 0 of the other number line, and now the positives were labeled going up, and negatives labeled going down. So let's say I wanted to show 3, 5 linked together. First of all, we write them like that. That's called an ordered pair. The first value is the x value, the x-axis, the 3. Now, of course, that second axis also has a name. Many of you probably guessed it. It's called the y-axis, or sometimes the dependent axis. So the 5 then would go on that axis up here. To show that they're linked together, now we don't actually put those two blue dots that I put on there. What we do is we do this. We trace them up where they intersect. We put one dot there. That dot represents both the 3 for x and the 5 for y. Its shadow on the axis is its value. So let's say I put a dot right here. What's its value? Well, its x value is 2, right? Its y value is -3. Simple enough, right? So we have the axes, we have the data points. The center here where there's both of the zeros are at is called the origin. Something that might be a little more tricky to graph. What if I had you plot the point 4, 0? Where would that go? Well, from the center I go over 4 on the x-axis. Where's 0 for y? Right there. That's 4, 0. What if I have you plot the point 0, 2? Well, where's the 0 on the x? Right there. Where's the 2 for the y? Up 2. So that's the point right there.
So you're going to just be referring to them as x and y and not independent?
Usually it's x and y for what we're going to do, yeah.
Okay.
If we were in statistics, it would be independent and dependent. The reason being is the independent axis is the one that you get to pick the value for. And then once you pick that value, it determines the value of the other one. The other value depends on it.
Okay.
Well, why do we care about plotting points on a graph? Outside of statistics, where we actually might, look at someone's height and their weight and graph them together, or you might look at time and speed, or time and distance traveled, things like that. Well, in algebra, we might have equations like this. We've solved equations with one variable. We've solved a lot of equations with one variable, but this one has two variables. We cannot solve this and get a single answer for it. There are actually an infinite number of solutions for this, because no matter what value we pick for x, there's going to be a value for y. We'll calculate out. So to show the values of this, the easiest way to show the solution for this is to graph it. To do that, we start with a table. And in our table, we're going to pick values for x and figure out what y has to be. So let's say I pick values of, I'm just going to pick some scattered across the graph. Let's say -2, 0, and +2 for x. And let's see what y comes out to be. If x is -2, y equals 2x minus 3. So y is going to be 2 times -2 goes in where the x is, minus 3. What's 2 times -2? -4. What's -4 minus 3? -7. So x is -2 and y is -7, giving us the ordered pair -2, -7. So -2, 1, 2, 3, 4, 5, 6, 7. There's our first point. If x is 0, y is going to be 2 times 0 minus 3. 2 times 0 is 0. 0 minus 3 is -3. When x is 0, y is -3, giving us the ordered pair 0, -3. So 0, -3 is right there. If x is +2, y is going to be 2 times 2 minus 3. What's 2 times 2? 4 minus 3, 1. So when x is 2, y is 1, giving us the ordered pair 2, 1. So 2, 1 is right there. Get that. Those 3 points fall in a line, so it's a straight line through them. What does that line mean? Well, that line is all of the possible solutions. If x is 1, I can follow that down to the graph, follow it over. Y has to be -1. If x is -1, I follow it down to the graph, follow it over. Y is -5. I can find any solution to that equation from that line. Any point, or I just pick a random point, like here. This is, trace this down, x is 1.5, y is going to be 0.5. Actually, y would be 0, actually. Anyway, it doesn't matter. You pick any point on that graph, you find its x-coordinate and y-coordinate. It is a solution to that equation. It makes that equation true. Now, not all equations form a line on the graph. Some of them form different shapes. For example, we can have an equation like this. And let's pick some points and see what we get. So I'm going to pick some points again, -2, 0, and 2. If x is -2, well then y is going to be -2 squared minus 4. What's -2 squared? +4. Minus 4 is 0. So that gives us the point -2, 0. So -2, 0. Right there is a point. If x is 0, y is 0 squared minus 4. What's 0 squared? 0 minus 4? -4. So we get the point 0, -4. Right there. If x is 2, y is going to be 2 squared minus 4. What's 2 squared? 4. 4 minus 4 is 0. So So we get 2, 0. So 1, 2, 0 right there. Obviously not a straight line. It's going to have some sort of a bend. But at this point, we don't quite have enough information to know exactly what shape it is. Is it a V or is it some sort of a curve? What is it? So we're going to pick some more points. I'm going to pick like x equals -1 here and x equals +1. See what I get. So, but we didn't figure out the graph, but the points we've put on there have told us what values to use for x to get more points. So let's use -1. If x is -1, y is -1 squared minus 4. What's -1 squared? 1 minus 4, -3. So -1, -3. This is the point right here. If x is +1, y is 1 squared minus 4. What's 1 squared? 1 minus 4, -3. So 1, -3. Right there. Like that. What do you think? Not so bad? Yes? Interesting?
Why would a person use this? What would they use it for?
All sorts of fun stuff.
Absolutely nothing.
Okay.
Well, I'll give you one answer.
What?
I'm going to give you a worksheet with a bunch of them on it that you can use it for. If you get into economics, all your supply and demand curves are going to be like this. Cost, your marginal cost, marginal profit curves are going to be like this. There's a lot of it. When you get into management, you're going to be reading a lot of graphs like this.
All you know is you don't want your company to do this.
It depends. Sometimes that's a good thing.
Come back up.
It has to be like that, but you go, woohoo.
Well, it depends on what you're graphing. If you're graphing profits, that's bad. If you're graphing expenses, that's a good thing. Or losses, that's a good thing. There's a new quiz that's going to be due tomorrow at 11:59 p.m. There's a new homework that is going to be due Monday. But I'm also going to pass out a worksheet here. And the reason I'm ending early is because if you want to take class time to work on it with somebody else, you can. This worksheet is graphing these equations, plotting points. So just figure out what the missing points are and try to fill in the graph with them.
This is